Welcome back. So in this video, we're going to put all of the equations into the steady state, which isn't so hard. We're going to start with the labor supply of capital, which was CT sigma C, LT sigma L is equal to WT over PT. So all we do is we change the T's to S's. Here there's no shocks. So we just get CSS sigma C, LSS sigma L is equal to WSS over PSS. Okay, and we're done. That's all you have to do. The next equation we'll look at is the Euler equation, which is the expectation of time t of CT plus 1 over CT sigma C is equal to beta times 1 minus delta expectation plus expectation at time t of RSS divided by PSS. Okay, so when we put this one in the steady state, change colors, why not? We're going to get, we can drop the expectation because we know we're in the steady state. We're not expecting anything anymore. Nothing ever changes. Oh, and I just was on total autopilot. I already wrote RSS, PSS. I apologize for that. These should be T plus 1. RT plus 1 and PT plus 1. Okay, so here we are. And right away you can see that this is a 1, right? It's CSS over CSS, so we're going to get 1 over beta is equal to 1 minus delta plus RSS over PSS. And, okay, so there we go. This is our answer. Notice, however, that we could solve this. Let's not draw a box yet. We could solve this for the real rental rate of capital. This is the real rental rate of capital, and so we could solve this just by subtracting 1 minus delta, right? So we could have RSS over PSS is equal to 1 over beta. 1 over beta minus 1 minus delta. Yeah. So right away, we found a price. Okay, so we know that the real rate of return on capital is going to be equal to the inverse of the time preference of the discount factor, and then we're going to subtract off 1, and we're going to add the rate of depreciation. So the more capital depreciates, the higher the price of renting that capital will be, and the greater people's time preference, also the lower the price will be, right? Because as beta gets smaller, and as people get less impatient, they care less about the future, they care more about the present. You have to pay them more to part with their goods, to part with their present consumption. Okay, so there you go. That's your Euler equation. We also have the budget constraint, which there's nothing special here. We're just going to have PSS CSS plus PSS ISS is going to be equal to WSS LSS plus RSS KSS. Okay, I just wrote it straight into the steady state. There's no simplifications to do here. You just have to change the T's to S's. And we're just remembering that everything goes to the steady state, not just one variable or two variables. It's a property of the whole system. It's not a property of just 1 or 2 variables. Okay, so last we have the law of motion of capital, which was KT is equal to 1 minus delta KT minus 1 plus IT. And as you can probably see, we're going to get KSS on both sides when we send this to the steady state. So maybe it's interesting to solve for ISS. Or KSS. Let's solve for KSS. So we need to subtract this part to the left. So we'll have KSS. And I'm going to factor, well, I won't factor yet. Let's write this down first so we know what we're dealing with. Now I'm going to factor the KSS through. Okay, so we're going to have KSS minus KSS. Now we have minus minus, so we have plus delta KSS is equal to ISS. Okay, and so this cancels, and we just get that ISS is equal to delta KSS. Okay, and that should maybe make sense. It means that in the steady state, we're just going to replace the steady state capital every period, right? Because every period we lose delta and we just put it back. We're going to lose delta times KSS, so we're going to invest back delta KSS, or delta KSS, and so then KSS is always the same, right? That makes sense. And that's the household. Okay. So do the firm, and I will do it together in the next video. So go back to your boxes, look at all the firm equations, set them to the steady state, and when you see simplifications, make the simplifications. I'll see you there.